Thank you very much for coming this afternoon. I know it's State of Origin night, so we'll try to make it quick and short for you and everything else. My name is Piagno. I'm an architect, total budget group architect at Cairns. With me presenting tonight is also Allwood from Total Budget Group Architects and Gisela Jung from CA Architects from Cairns. We were asked earlier this year to do a presentation at the Design Build Expo in Brisbane in May. So the topic we chose at that expo was sustainable tropical building design. And the purpose of the expo was not only to present about sustainable tropical design, but also to promote the Tropical Green Building Network, and also to help launch the Advanced Tropical Building Reference Directory. So some of this you'll probably, it'll be common knowledge for us up here, but we thought we wanted to, we didn't know what audience we were going to get down in Brisbane, and so we were asked by the TGM if we could redo the presentation up here for our the TGM group. So hopefully we won't bore you too much. So Brisbane we know. So what does sustainable mean? As defined by the Oxford Dictionary, sustainable means being able to be maintained at a certain rate or level, sustainable economic growth, conserving our ecological balance by avoiding depletion of natural resources, our fundamental commitment to sustainable development. Wikipedia, for users of Google, defines sustainability as the capacity to endure. For humans, sustainability is a long-term maintenance of responsibility, which has environmental, economic and social dimensions, encompasses the concept of stewardship and responsible management of resource use. Therefore, what does that mean in terms of sustainable tropical design? Sustainable tropical design is about reducing the impacts on our environment by designing, it's about reducing the impact by designing constructed buildings that are appropriate for a very hot and humid climate and are healthy and comfortable for building users. A recent article written by Jane Perkins that I've discovered on the Green Building Source website, she describes the notion that sustainable design is becoming convoluted. Many developers and their clients have an idea as to what it means to design sustainability, but the perception is often far removed from actual processes. Not to be confused with green building and the renewable energy technologies that fall into the sector, such as solar panels, wind turbines. Sustainable design is about making clever architectural choices that enable a space to run optimally without reliance on various technologies and sustainable and natural resources. This kind of action is defined by the inclusion, it's not defined by the inclusion of the water tanks or photovoltaics. These fixtures simply add to the holistic sustainable design concept. Well, at the expo, we're also promoting the Tropical Green Building Network. It's a group, as you know, of a group of local professionals of expertise in creating sustainable built environments in the tropics. The work of this group involves supporting and promoting new green building technology systems services to the tropics. The group is supported by the local council and by Greenbuild. The Greenbuild TGM has been functioning since 2009. The main aim is to encourage in learning leadership in the area of creating a sustainable built environment. The network also aims to promote information sharing and collaboration between individuals and organisations in the industry to improve practices towards sustainability. The network has over 200 members from varied professionals including builders, home designers, architects, government advisors, engineers, town planners, university lecturers, building technicians, building contractors and suppliers. So the TGM was at the expo also to launch the Advancing Green Build Reference Directory. It's a directory that's been established to listing the businesses of Queensland with the expertise in tropical building. I think that directory's on our website, isn't it, Emma?
Mm-hmm.
Emma, sorry.
Yeah.
And I believe now Vivi's doing a further investigation development of that shortly as well.
Yeah, strategies coming.
So the directory aims to identify the capacity of North Queensland Green North sector and also to guide industry development initiatives such as market development, investment attraction, infrastructure requirements, education and training needs, and future direction to grow the sector. The hope is for a direction to promote green sustainable businesses not only within our tropical region but also to the rest of the world. Where is the tropical zone? Aristotle once described as a place that is too hot and humid for human habitation. The tropical zone is also referred to as a torrid zone. The tropic is a region of the Earth surrounding the equator limited by tropical Cancer and tropical Capricorn. It's defined by that slight pinkish colour on the screen. It's a little bit of a reddish colour. The tropics include all the areas of the Earth where the sun reaches a point directly overhead at least once during the solar year. That's an important point to remember. Currently, about 40% of the human population lives within the tropical zone, and it's perceived by 2060 that this will increase to 60% of the human population living in the tropics. What does this mean? Due to the increased population, the economic growth forecast for the world's tropical zone, including India, Southeast Asia, China, Vietnam, South America, Africa, will lead to increased demand of innovative, climate-resistant, energy-efficient tropical design solutions. Let's hope so. Tropical design, Queensland architects, home designers, builders are taking advantage of this and rapidly building up our reputation to deliver sustainable tropical building projects. So, before we showcase some of our tropical build projects of the north, we need to explain some of the basic sustainable design principles that we generally work to. I think I'm practicing or preaching to already converted people understand. Preservation of natural resources, sustainable and renewable recyclable construction materials, engaging passive cycle design, engaging passive ventilation, water efficiency and saving, energy efficiency and saving, insulation, lighting, and so on. So I'll only touch on the basic three passive design principles that most tropical designs adhere to. The first one is orientation. Siting the building and its orientation is a fundamental design principle. Orientating the building to minimise solar heat gain. Orientating the building to maximise airflow. As previously explained, the sun at some point during the year, solar years overhead. In Cairns, as you see by the solar chart on the screen, we have the sun that comes from the north in winter and in the south in summer. Therefore, the ideal orientation for a building in the north would be along an east-west orientation with well-shaded north and south walls. Air movement over the body creates a feeling of coolness due to the evaporation of moisture of the skin. Therefore, our designs needs to emulate this wherever possible. Maximise the breezes or natural ventilation within the building, encourage air movement, either by passive design or by mechanical means. Removing the hot air from the building and from the roof space, designing buildings for a mixed mode use. And solar protection. The last of the 3 points I've described. Walls retain heat, therefore need to be protected and shade the walls from the sun and prevent the heat from transferring into the building. We also need to reflect the heat from the roof. Use large overhangs. Solar shades over windows and openings to prevent the heat from entering is important. We need to provide a holistic approach to sustainable building design. Now, as we know these few basic principles, I'll pass you over to Belinda, who will then describe these further in some recent residential examples.
Thanks, Eddie. That was awesome. Okay, from Eddie's introduction, obviously we delivered this to a very general mixed audience in Brisbane. A lot of people here are very familiar with these principles that we're talking about, so hopefully that will be so. First, I just want to let you know that a couple of the images that I'm including in this segment are of Indigenous Australian ethno-architecture and contain images of people that are now deceased. Okay. Now, from Eddie's introduction, we learned basically a very good broad overview of some of the basic principles of tropical sustainable design. In particular, the passive solar, passive ventilation. So before I launch into the showcase of recent housing projects up here, which is what I'm mainly going to show you, just thought we'd take a quick trip around the world and back in time to have a look at some sustainable housing design solutions that have been developed over millennia quite effectively. So top image here is in South America in the Amazon. It's the example of a house type called palafito, which translates as a stilt house. Now, from what Eddie told us, the basic solar passive design technique of keeping, minimising the solar heat gain, so basically a big roof to keep the heat off and the sun out, and open walls to maximise ventilation. This example, I mean, that's it in a nutshell. It doesn't get much better than that. Open walls and a roof. That's sustainable tropical design in a nutshell. Next image. Quite often, as architects or designers, we get asked by people who aren't from up here, how do you design for the tropics? And really, quite often what it comes down to is putting a big hat on a building, a big roof, a big hat to keep the rain off and keep the sun out. So that second example from Africa is a Senegalese boathouse. And as far as cross ventilation goes, it's a bit hard to tell from that how effectively that works. But I thought, brilliant example of a big hat on a building. Okay, moving along. These two images are examples of a Malay longhouse. And it's a type of building that has been used for millennia throughout Asia, not just Malaysia. One of the points here I want to bring to your attention is something that Eddie touched on, which is flexible design. Now, in the bottom image there you can see, well, this is a very long axial house. It's long and thin, it's good for cross ventilation. The half of the house on the right-hand side there is a very flexible space. It's communal space. This building is designed spatially as a communal building. It'll hold several families and encompasses the notion of flexible design. The top image you can see, again, the idea of the big hat to keep sun off, to keep the rain out. High roof spaces to promote thermal cooling, let the air naturally rise and vent out. And like I said, good cross ventilation. So a bit closer to home now, Papua New Guinea. Raised platform structures, all of these that you've been looking at actually are raised platform structures. They promote cooling by getting breezes under the house and also getting the living area up higher. So you're capturing breezes through the house, as well as keeping away from the crawlies, creepy crawlies. And and summer monsoonal rains, quite often you get high overland flow of water, so it's keeping everybody nice and high and away out of the water. In Australia, these are the Indigenous examples of a building type from Arnhem Land in Northern Territory. This is a building type that I understand is quite often used in Cape York as well. Now, again, it's a raised platform to keep out of the floodwaters, keep away from the creepy crawlies and the snakes. It's a big roof, essentially, to keep the rain off and the sun out, and open ends to keep maximum breezes coming through. Another point about this design, quite often they did fires underneath the platform with the idea the smoke kept mosquitoes at bay. Alright, so back home and in here and now, and onto a bunch of buildings designed by some of our local architects and designers, some of which are in the room here tonight, so I hope I do you justice. This one is a house at Mission Beach designed by Chris and Ike, who's with us. The feature I want to point out with this particular house, I understand it was an award-winning house a few years ago, it's, the spatial planning is what we term pavilion style. And if you look at the floor plan on the left there, you can see the living areas are separated by open veranda space or covered veranda areas. Now this promotes breezes, getting living areas with outdoor areas between, maximises breezes between the buildings, and it also allows for flexibility in the living and spatial design. This is an internal shot of part of the building, just so you can see one of the other features, which is maximising the wall area that can open up to let the breezes through. And it also allows you to control the flexibility of the space. So, in fact, your indoor and outdoor zones become blurred. There's a lot of flexibility now. Deep overhangs for solar protection and keeping the rain, and high ceilings there to allow the hot air to rise. And in the next image, I think you can see roof vents once that hot air has risen that can vent out the top there. So it's promoting a good cross flow of air and also raising the hot air and venting it out the top. This next project is by Total Project Group Architects. It's a display home at Argentine up at Palm Cove. Now, this place, again, if you look at the floor plan, uses the notion of pavilion style design, getting the outdoor areas punching through the living areas. My mouse bar there. And also the high level roof vent again and high ceilings. This photo, if you look closely, it's quite hard to distinguish the kind of border between indoor and outdoor spaces. Oh damn, sorry about that. Just lack of mouse. The doors slide fully and retract into the walls, so it's very hard to determine where the zones interface is there, and in effect you're turning the whole house into a nice big veranda space to live on. Okay, this project also sourced natural stone and locally sourced stone and timber. Okay. Next house is up at Port Douglas by Total Project Group Architects. Again, it's pavilion style, but it's a little bit more formal in its spatial planning. It's a lot more axial. The outdoor covered areas, if you can see that arrow moving down, are quite formal axes, and then that one cutting across the building there. Okay, it's still pavilions. You've got sleeping areas there, and then a living area here. Narrow in design to promote cross ventilation. And moving right on. The next images, this group of images, show those in-between spaces between the pavilions, and also kind of highlight the importance of the natural landscaping in a design like this. Particularly when you're designing on a suburban block, the idea of privacy can be difficult to achieve if you're opening up your spatial planning and opening up your walls to allow the breezes through. So you can use landscaping as screening as well as shading. As you can see in this shot of that same house, where the planting is used as screening and also shading. This image also illustrates quite well the idea of opening up the walls, so you're letting outdoors in, maximising the breezes. But one of the other points I like to make is, as you're all probably aware, one of the things we have to battle with up here is mould growth. And when designing, if you can design to incorporate as much natural light, and ventilation as possible, it really helps to keep that mould growth down. This project is another Total Project Group house, and it's about to commence construction. This image I just wanted to include to illustrate again, it doesn't matter whether you're talking about a top-end house like this, budget-wise, or a cheaper house. The principles of passive solar design and passive ventilation are common This building, this living area, you can see it's 1 room wide, so, oops, there it is. So maximum ventilation across, also the high ceilings and high windows to allow that thermal venting. Hot air can get out up high. Okay, whoa. Sorry, a little bit of technology trouble there. Well, there we go. I'm not going to touch that mouse pad again, I'm just going to do the arrow keys. Alright, next house. This one is a house by the architects. Peter Pierce is not here tonight, but this is actually won the best house in Cairns award recently at the Farm of Queensland Architecture Awards. House up in Woodfield. Lovely, lovely little house. If you look at, risk that mousey thing again. Damn it, there it is. the floor plan there. Okay, pavilion style again, but in a different sort of arrangement. You've got the breezeways between the pavilions, very lineal house that breezes can get through. The notion of flexible design that he touched on earlier is very present in the living area of this. Traditionally, houses for the tropics were living areas plus verandas. This house has been designed so the living area essentially is a veranda. You can open up the doors all along that front elevation there, and you can just see there's balustrading on the outside, directly on the outside. So if you open all that up, you're effectively turning your living area into a veranda. Incorporating flexible design like that is saving on area. You're not building additional verandas, so saving materials, saving construction cost. And of course, that's sustainable in itself. Same house by Peter. This is a view from one of the breezeways looking back towards that living area. Peter installed photovoltaic cells after the house was finished, and he has got 1 air conditioner, I think, in the bedroom that they use occasionally during the summer. The PV cells are running very effectively. He tells me that their quarterly bill varies between about $13 and $15 for a 2 kilowatt system on the roof.
He's not having trouble with the shade?
Hey?
He's not having trouble with the shade because I notice he's in the forest.
Well, evidently not. I mean, he's running a small pool filter a couple of hours a day and an air conditioner through the night summer, and they were the figures that he was getting. That was his bill over water. So I think that's pretty indicative that he's not having trouble with shade. Now, this is a house by somebody else in the room here tonight, Sophie. I think this house might be nearing construction, if not finished. Yeah,
Nice, yeah.
recently
A
constructed.
couple of months.
Okay, an example of a house that's been designed as a project home, so fairly low budget, very standard building methods and materials, but incorporating those passive solar design principles that we've touched on a few times already, maximising cross ventilation by incorporating where's that thing? Arrow there, outdoor areas in the middle of the building. Big overhangs to keep the sun off the walls, keep the rain out. So again, it doesn't matter what your budget, if you pay attention to those basic design principles, you're off to a really good start. And this is the last local house I want to show you. It's a lovely little house by CA Architects, completed in 2006 for a construction cost of $120,000, nearly $120,000. Now, it's a very small house, as you can see by the plan here. It's essentially a studio type house. However, for a couple, it's got everything you really need in it. So it's low budget. They've visited their needs and established what they need, and really not put in any more than that. And there's not a metre squared too short or too much in this building, but it's got everything you need to be comfortable in a house. There's a bathroom, storage kitchen, living area and sleeping area, and 2 outdoor areas. A very good sustainable solution from the point of view of establishing what your needs actually are and going overboard with it. This house has also been designed to operate entirely off-grid. Again, those basic principles you can see at play. Very narrow design, so maximum cross ventilation, high ceilings to allow hot air to rise and escape out those top windows that you can see there. Being in Korea, slightly different climate as you're all aware. Cold winters, so this house has got a small combustion stove, and you can just pick that flue up in the top left-hand corner there. But being a very small space, it would be quite effective to heat as well as cool. So that concludes the examples of tropical sustainable houses, and I'll hand you back to Eddie now to go through a commercial project.
Thanks, Belinda. So Anthony spoke, we didn't want to also focus just on residential buildings. We wanted to give our audience out there a broad cross-section of works up here. And we not only touch on residential sustainable buildings, but we do education, and Gisela will touch on some commercial projects. So on the educational side, we demonstrated the Cairns TAFE Block J. It's a purpose-built precinct for a range of health, community care and sustainable programs. It was meant to develop an industry and community showcase demonstrating best practice in reducing operating maintenance costs, improving usability and occupant health within a tropical environment for an educational building. The existing building was a single-storey, 1,490 square metre development. The building was a pavilion style with classrooms around a centre courtyard, and it was constructed in 1986. Our project brief was to refurbish the existing building and add an additional 460 square metres for an executive staff. The planning form, as you can see on the screen, Area 1 is the executive wing, Area 2 is the health precinct, Area 3 is international student area, and Area 4 is the flexible educational wing. The building addresses two architectural concerns when you design hot unit climates, as we mentioned before: orientation of building form, the long axis of the building. Thankfully, it faced the north, south, and the west facades were dominated by blank walls. The structure is long and thin, with single depth rooms, similar to what Belinda was describing before in the domestic construction. Allows for good cross ventilation, open passageways to facilitate that. Large overhangs to protect the building, and walkways from the sun and heavy tropical rains. So this building was designed to achieve a 5-star outcome under the Green Star Educational V1 tool developed by the Green Building Council of Australia. It's significant that that's the first one in the educational buildings in Queensland. We're still waiting for the result to come through on the as-built rating. The red box, if no one knows the project at all, is the executive wing, and the grey parapet features the flexible education wing, which houses the green room, which demonstrates the sustainability initiatives throughout the building with interactive digital display and interpretive signage. So in the design, the slide illustrates a cross-section through the education wing. It demonstrates a large roof overhang to shade the walls, therefore reducing the heat stored in the walls. The building was also built using lightweight materials. The purpose of that was not to store the heat, low thermal mass, therefore allows the heat to radiate and conduct through the wall quickly. Both the walls and roof are also well insulated to provide that thermal break and reduce the amount of heat transfer. All these principles help to work towards using less energy, electricity and cooling. This photo demonstrates the large overhang and the sunshades to shade the walls and reduce the heat gain, and also it will reduce the amount of glare entering into the building to provide that occupant comfort. Cross ventilation, energy management of the building involves a reduction of mechanical cooling by passive ventilation. Passive ventilation and air conditioning system are linked to a building management system and the weather station on the roof. When the climatic conditions are ideal, it automatically shuts down the air conditioning system and informs the occupant that the building is in natural ventilation mode. Therefore, the occupants are encouraged to go and open windows and doors to allow the ventilation to come through. When the building was initially modelled, the modelling predicted that it would only operate 13 days out of the whole year. We would get the climatic conditions adequate to operate as a natural mode ventilation. In its first year of operation, it operated well over 28 days. And I know the staff and students tend to operate more frequently in the natural mode. They enjoy the actually fresh air. It just makes them more alert, and the students more alert into that space as well, so it helps the education. The building's designed with a couple of means of natural ventilation. There's a convection system, hot air rises, so Block J uses hot air windows, roof vents to exhaust hot air from the room, creating air flows that draws cooler, fresh air through lower openings. There's a mechanical ventilation. Fans are used to create air movement as well, especially in those still days. The building sensors are also onto the windows and vents. Therefore, when the windows and vents are open, it automatically shuts down the air conditioning. Therefore, you're not wasting the energy. You can have the opportunity to override that if you wish. Well, this photo shows Block J's windows and doors facing north, being well protected by the sunshade. The photo shows lots of natural daylight entering the building, reducing the need for electric lights. The sliding doors allow flexibility, good cross ventilation. The glass in the windows and the doors use a high efficiency glass and shaded to reduce the heat gain. Lighting. The lighting used in Block J is very efficient, energy efficient lights. They're fitted with motion sensors, so lights are automatically turned off when the rooms are not used. Lights near the windows are also fitted with sensors, so they turn off when there's insufficient daylight. That photo doesn't really show it, but the lights are on that day. The main component of the energy use is air conditioning in the buildings. Block J uses an efficient gas-fired air conditioning system. It's highly efficient, much quieter than electric, and simple to maintain. They tend to be about 10% more efficient. However, the gas-driven system tends to be 20% more expensive than electricity, but they offer a more environmentally friendly and reduce the greenhouse gases considerably. So there's an environmental plus on that. It also has an energy recovery system throughout the building. I think Gisela might touch a little bit more on her energy recovery system on her commercial project. Air conditioning related energy used is reduced by using the temperature exhaust to pre-cool the fresh air brought into the building. Also, the air conditioning has a byproduct that can also generate hot water through the heat rejection process. But if the tape would use, unfortunately, we weren't able to use it because it generated too much hot water for tape to take on board. Block J uses water conservation strategies. We estimated that we've reduced water by 49%. Uses water efficient fixtures, tap weed, reduced water flow devices, low flush toilet systems, smart urinals. They started to become more and more common through our buildings. Water use throughout Block J is metered. Therefore, this information is connected back to the building management system, so it can be displayed to inform the builders. So when people tend to be informed, they tend to then reduce the energy. Block J has 6 rainwater tanks, total capacity of well over 30,000 litres. Rainwater is collected from the roof and stored in these tanks for reuse of toilet flushing, irrigation and washdown areas. One of the main conservation areas in Block J is the centre or the landscaping. It's called a xeriscape, which initially literally means dryscape. It's designed to require no watering. Xeriscape is designed to create a good soil health and use of natural plants that are suited to the local climate for cycle. All plants in Block J are native, drought tolerant, trees, shrubs and grasses, and the gardens also well mulched to reduce the loss of water in organic matter. The central courtyard in Block J is features a bioretention basin, which is intended to detain storm water and allow it to filter through the vegetation and media. The pollutants are retained through fine filtration and absorption and some biological uptake. In a small rain event, much of the rainwater will go to the water table. In a heavy event, the water is collected by a perforated drains and then directed through the stormwater system. Block J has also a solar hot water unit. The solar hot water unit heats up the water and preheats the water prior to circulating around the building, giving an extra boost happened by the instantaneous heat gas units at the outlets. The solar preheat reduces the energy used by the instantaneous units, while the boost prevents water from being wasted and drained while we're waiting for the hot water to get to the tap. The building also uses photovoltaic, approximately 45 kilowatts per day of electric power each day, and equates to about power of three houses, domestic houses. Again, the photovoltaic and the water, it's all monitored back through the building management system. So it informs the users how much energy being used. It's also been used as an educational tool for demonstrating the sustainable outcomes of the building. One of the big items that we incorporated in the building was a refurbishment of the existing building. It was to design and retain as much of the existing, it was to recycle the building. So we retained the existing floor, the existing structure, and reused materials from the demolition. For example, the concrete slabs were retained, were cut up and used as paving slabs in the landscaping area. The hardwood veranda posts were used for wall framing, as you can see by the feature parapet wall and the feature lobby entry wall. New timber used in Block J was the certified resource sustainable managed forest timbers, and also plasterboard carpets and other furniture in Block J have a high recycled content. And of course the products used in Block J are loaded from VOCs and formaldehyde. So that really demonstrated a sustainable education building that we have in North Queensland. I'll ask Gisela to present some larger commercial.
I'll just be talking about two very different commercial projects which we completed in the last 5 years together with the Brisbane firm Cox Rayner. We've been working within the last maybe 12, 13 years. Apart from them, our whole consultant team usually is entirely Cairns based. So all of our consultants have got a pretty good idea of what the climate means and that we're designing for. In 2003, we've completed stage 1 of the government office building, and back then it achieved a 5-star ABGR rating, which was the first, and it was the first building that actually achieved a rating like that in Australia. Only 4 years later, the government actually decided that it needed to expand, and we were asked to design another building that had about double the size of the first stage, so about 10,000 square meters of NLA to house the rest of their government buildings or agencies that's been really spread around Cairns. It's a 9-story building, and it was designed to be integrated with and enhancing the previous stage building, and it also had to achieve a minimum of 5-star, Green Star. I think during the early design process we thought, oh well, why not try for the 6-star rating, and while we were thinking about that we thought, oh, I think we should maybe also go for the interiors rating and an actual as-built rating to just round that up and really show that we can deliver a project like that. To do that is probably not unusual in other Australian capital cities, but it's never been achieved in a remote or tropical location. I think what it is, there's a lot of Green Star points within the rating scheme that seem really easy in a big city, but as soon as you're in a remote location, things like transport and land use, ecology and sort of material selection becomes quite difficult, or even sort of recycling aspects of materials. And that limitation was very obvious when we were designing William McCormick Place. So we started in the beginning, just like every other project, we started with the site and context and worked out our choice of material, the streetscape and environmental amenity from there. We had a pretty stringent brief from the government what size floor plate they want as a minimum on each floor. So we really had to balance that with an effective floor plate for Green Star. And we managed to put the building on a broadly east-west axis to allow maximum solar shading with minimum applied sun shading. So we put all the required emergency stairs on the east and west to further increase our sun shading on those sides. And we put the core of the building towards the centre and southern facade to shield off the space from the southern summer sun. I don't think you can barely sort of see it at the bottom of the page. All windows to the west and east facade have been kept small, and the ones in the south and north are large, but we still purposely designed all sun shading for the building that also double up as maintenance walkways for the facade, so we can effectively clean and maintain the building. All the office windows are double glazed, which obviously helped us, but it was mainly done for acoustic control for the offices. Being a government building, there was not much talk about being able to naturally ventilate it. It was quite strict that the brief was to be an air-conditioned office building. So we just had to get it as tight as possible to make it effective and use as little energy as possible. In the interiors, there's a number of different design strategies that obviously all play together. There's the optimal shading and thermal insulation, high windows, high ceiling, light finishes for best daylighting. As before, the artificial lighting is grouped into zones, so and equipped with daylight sensors, so the lights near the windows are not as bright as the ones to the centre of the building, and as the clouds increase or you get more sun, the lights just adjust automatically.
Is it double glazing or single?
It's a double glazed facade, yeah. I think one of the most successful features in this office building that we found was the introduction of ceiling fans in combination with the air conditioning, which is probably very successful in any domestic developments, but it hasn't really been done in our commercial project. And it's really helped us to ensure some more innovation points with Green Star, and it's been extremely successful. Those fans run quite slow, so they're not going to blow up all your papers on your desk while they're going, which obviously was important again.
You're able to set the temperature up higher in the air conditioning.
Yeah, so and having all the fans and the air movement, your perceptive coolness has helped us to set the air conditioning at a higher level than usual, so instead of feeding air in, our temperature was around the 24 degree, and you just felt a lot cooler because the air was constantly moving.
Were the air fans facing down or up?
I'm not sure how these work. I think it's quite a detailed modelling when you look at one of those fans and what the air actually does. I think it's doing a kind of a spiral. It's not really just down or up.
If you reverse it, you'd probably get better circulation.
Yeah, well, these fans, because they're only a two-blade with a sort of...
The period will auto-arm in 5 minutes. To prevent auto-arming, kick in PIN number or ensure motion detector registers your presence.
We need to move.
I'll
Take your time.
Run out the door.
Obviously, for the whole fit out, we use low VOC materials, paints, and which I believe should be fairly standard nowadays, or I'd like it to be fairly standard. And a feature that you don't really see on those photos is that we've got a central stair which we require for fire escape, but we also try to make it as pleasing as possible, so we can actually encourage people to use those stairs and decrease or reduce the number of journeys the lift makes, which works for small journeys, but we wouldn't have people moving up 10 stories. William McCormack Place was awarded all points available in the categories of water, energy and energy, which was an amazing achievement of the engineering team, and we are really proud of that. I'm not even going to go into details. If you want to have details, I just saw Graham walking in, so you can ask him everything about it.
Including the fan question.
That was just perfect, thank you. We obviously have got, as you can see, a major thermal energy storage system with air conditioning chillers running only at night, so it provides a direct energy reduction and is providing significant water savings without additional energy. That's my little architectural summary of what it is. We've got 400 square meters of photovoltaics on the roof, which in layman terms means it's running all the lighting in the building. And another feature is the integrated water management system, which obviously uses recycled grey water for toilets and irrigation. From an architectural point of view, again, we continuously strive to reduce the amount of air-conditioned space a building really needs. So the foyer has been conceived as an external space to encourage the interaction with the Cairns climate. The large fans activate on very still days, and I mean really very still days only, because there's always a breeze in that foyer. On the ground floor, we've located a row of shared large meeting rooms which can be booked throughout the whole office tower, and that helped us to not have the large meeting rooms on every level, but they're shared at the ground level, and therefore we've again reduced the areas of the building and the tenancies really need. We've got lush greenery in the foyer, which doesn't look so lush on this photo, but it's growing extremely well, and we think that's really one of the main factors that makes the foyer so successful. I think greenery is always an aspect that gets easily forgotten in the sort of grand planning scheme of things. So I think the building has really been designed with the Cairns climate in mind, and the tropical climate was really at the forefront of every our decision-making process. And I think in the end, the environment rather than the building shell was the principal driving force in our design. Just going to go over to a very different project that everyone in Cairns knows, but it was very new to everyone down in Brisbane. The Marina Point won the 2010 Final Precinct Building of the Year, and we've submitted it for the World Architecture Awards, but we only made it on the shortlist. I'm just going to quote from the text that the designer has given us. Seeing Cairns as a city of edges rather than spaces, our aim was to culminate the city's main axis into a new public space rather than a single building. The buildings are designed to encapsulate the languid tropical lifestyle of the north and the crafted nature of early boat-related architecture. Rather than forming one individual building, the concept was to create a small maritime village of pavilions set around a garden. I think that's been achieved by really creating 3 different buildings that are set around a central courtyard. So we've got the Cairns Yacht Club, we've got the bar and restaurant pavilion, and then we've got the boat shed sitting on the other side of it, detached from everything. And all these pavilions are linked by roofs, so they all just flow into one big space. The club and dining pavilion forms an L-shaped plan of activities addressing the space and the waterfront. with the dining pavilion really engaging with the water. I'm not sure if you've really ever seen this building from that perspective. I guess you might not have. Just like in any of the houses, with any forms of tilting screens, sliding screens up of the walls, blur the indoor and outdoor spaces so they all become one in the end. All the roof planes and orientation have, the building has been orientated to induce breezes, and the canopies are there to optimize the shade and driving rain protection. As you might have noticed, we actually turned our back to the southeasterlies in this case, so we can protect the bar space a little bit better. So rather than opening up the whole building and being blown up during the winter months. Well, I think these spaces have been more successful than we imagined, and certainly more successful than the client had imagined. And I think the precinct really acts as a small meeting place for the city. And the city probably has gained a little new lifestyle heart that everyone in the community can use. And it's not just closed away spaces for the club or for the visitors of the cafes. Being in Brisbane, we concluded our talk with this photo, which really reminded us all why we're in Cairns and what's so special about Cairns. And it really shows again that we all believe environmental principles like orientation, roof protection, natural ventilation, and the fact that we can adjust to different climatic conditions is a good sound environmental design principles, and then you can probably get away with any sophisticated technologies, although they always help as well. I'll get Eddie to wrap the session up.
Well, just to sum up and conclude, I'd like to thank Gisela and Belinda to help us in presenting in Brisbane, and we just portrayed down there that we up here had multiple challenges associated with planning, designing, constructing, operating sustainable buildings in a tropical environment as compared to other climates. Not only do we need to consider passive solar design, passive ventilation, sustainable construction materials, energy and water efficiency, we also need to consider anticipate the impact of extreme weather conditions like cyclones, heavy rainfall events, humidity, and deal with logistic challenges, prolonged wet seasons. There is a unique opportunity that Far North Queensland is one of the few developed tropical regions of the world to help now grow and foster our expertise with the rest of the world. With the launching of the Advanced Tropical Greenbelt Business Directory, we hope that we are poised now to share our expertise with the rest of the world. The local architects group are in advanced discussions with James Cook University to establish a school of tropical design, and it's been supported by many groups and organisations such as the Tropical Green Building Network. So we'll have soon be teaching others in the tropics around the world how to achieve a better sustainable tropical building design. So thank you. And we hope we did some justice for TPGM at the presentation in Brisbane, demonstrating some sustainable tropical building design across not only residential but education facilities and commercial buildings. So we just want to portray that our projects up here covers and captures all disciplines of building. So any specific questions? I'll open it up to the floor.
Can I just take a chance? My name is Vanessa, and I've got a lot to do with the Tropical Green Building Network, and I'd just like to take the chance to thank Eddie and Gisela and Belinda for your commitment to this and the time that you took also to do the presentation in Brisbane. And I know that it was the only sellout seminar at the Build Design Expo, from what I heard. And thank you very much on behalf of the Tropical Green Building Network, and again for presenting this to us tonight. And I'd also like to thank Didi, who put the money towards putting the booth at the Build Design Expo, and you know, putting momentum behind having the presentation delivered in Brisbane. And thank you for tonight very much.